Today, we're going under the hood of modern AI, and let's just forget all the usual buzzwords for a second. We're going to talk about the hidden architecture that's quietly changing everything, a new discipline called context engineering.
Now, we've all heard of prompt engineering, right? The idea that if you just phrase your question in the right way, you can get the AI to give you a better answer. It's been the hot news skill for anyone working with these large language models.
But what if I told you that's really just the tip of the iceberg? Because as these AI systems get more and more complex, it's becoming super clear that just prompting isn't the whole story. Not even close.
And this slide, well, it really lays out the difference. On the left, you've got prompt engineering. It's all about one interaction, a single string of text. You could almost call it an art form. But on the right, that's context engineering, and that's about the entire system. It's a science, really. The science of moving information around.
This quote just nails it. We're shifting from the art of writing a good prompt to the science of managing information. It's a huge evolution in how we think about and build AI.
So, okay, what is context engineering really? Well, here's the formal definition. But the key thing to get is that it's not just about the prompt you type in. It's about designing and managing the entire information payload. All the data, the tools, the memory, everything the AI needs to actually get a job done.
So how does this actually work? Well, the whole idea is really built on three main components. You can think of them as the three pillars of context. These three pillars create a kind of pipeline. It's how information flows through one of these advanced AI systems, from finding the right data in the first place to actually using it in a smart way.
First up, retrieval. This is ground zero. It's all about how the AI gets the raw info it needs to work with. Now, some of that might come from a user's prompt, sure, but the really powerful stuff involves techniques like retrieval augmented generation, or RAG. It's kind of like giving the AI its own library card. It can literally go look stuff up in databases or documents before it even tries to answer you.
Okay, so once the AI has all that raw data, it has to actually make sense of it. That's the second pillar, processing. This is where it transforms the information. It reasons through massive amounts of text, and, this part is incredible, it can improve its own work. It's like the AI writes a first draft and then acts as its own editor, critiquing and improving its answer again and again.
And finally, we get to management. This is the logistics center. You see, an AI has a kind of short-term memory called its context window, and it's limited. It just can't remember everything at once. So this pillar is all about the clever tricks, like organizing, compressing, and filing away information so the AI can pull out the right memory at the right time without getting overwhelmed.
All right, so those are the building blocks. Now for the fun part. What can you actually build with them? This is where things start to get really interesting.
The incredible thing is just how fast this is all moving. I mean, just a few years back in 2020, it was a huge breakthrough that an AI could just look things up. By 2023, AIs are using tools like calculators and search engines. And the next big thing? We're talking about multi-agent systems, literally teams of AIs working together. And what all this means is that we're seeing a massive leap in what these systems are. They're no longer just a simple text generator.
They're becoming a world interactor, and that is such a critical distinction. They're not just talking about the world anymore, they are actively participating in it. And listen, this isn't some far-off sci-fi stuff. We're talking about systems that exist today. AI that can use a calculator or search Google for you. Systems that actually remember the conversation you had with them yesterday. Even entire teams of specialized AIs that can collaborate to write code or do research.
But building these things is not easy.
There are huge challenges. One of the biggest is something researchers call the lost-in-the-middle problem. Basically, if you give an AI a really long document, it's pretty good at remembering the beginning and the end, but it tends to forget the details buried right in the middle. And we're not talking about a small dip in performance. Research shows that this problem can cause the AI's accuracy to drop by as much as 73%. That is a huge hit, and this is exactly the kind of thing that good context management, that third pillar we talked about, is meant to solve. So this brings us to a really critical question. With all these new powers, how do we even know how good these new systems are? How do we measure them?
Because, our old tests don't really cut it anymore. How do you give a letter grade to an AI that can use tools or remember things or work in a team? The short answer is, it's really, really complicated.
Well, the data shows we've still got a long, long way to go. This right here is from the Gaia benchmark.
It tests how well an AI does on real-world tasks, like planning a trip or managing your files. On that test, humans score a 92. GPT-4, one of the most advanced models out there, scores just a 15. That is a massive, massive gap.
And if you look at something even more specific, like trying to navigate a website to book a flight, the story is pretty similar. This is the leaderboard from a benchmark called Web Arena. Even the absolute best models are only succeeding about 60% of the time. So clearly there is a lot of room to get better.
So let's wrap this all up by looking ahead. What does the future hold? What are the big challenges that context engineering still has to solve?
Well, the to-do list is pretty long. For starters, we need a better theory of how context even works. We have to figure out how to scale these systems up to handle not just a few documents, but billions of tokens, like entire libraries worth of information. We also need to get way better at mixing in different kinds of data, like video and audio. And maybe most importantly, we have to make sure these super complex systems are actually safe and reliable. And all of this leaves us with one final, pretty provocative thought. Context engineering is giving AI memory. It's giving it tools, it's giving it the ability to collaborate. So the big question we have to ask ourselves is this: are we just building a better, more sophisticated tool, or are we actually engineering the foundations of a new kind of intelligence altogether? That's definitely something to think about.